So this, if a structure is not moving, then it means that the sum of the forces in each of the directions equals 0, and so does the sum of the moments in each direction equals 0. So the sum of the force in the x direction equals 0, sum of the force y direction equals 0, and it's good to put where you're labeling the positive. So I'm just going to up is positive, right is positive x, and anti-clockwise is positive m, and the sum of the moments equals 0. So the good thing about this one as well for global equilibrium is that we can do it around any point. So the sum of the moments around any point equals 0. So whether you have some sort of beam like this, yeah, so that's the roller support, the pin support here, and another roller support. The sum of the moments about this equals 0. So I'm going to write A, B, C. So sum of the moments about A equals 0, sum of the moments about B equals 0, and the sum of the moments about C equals 0. So this is a handy technique when we're doing things on problems. So I'm going to do a quick example of a global equilibrium. So say we have a pin joint attached to the wall and a beam coming off it, and then a cable attaching to the roof, something like that. So, and we also have, let's say, a force that acts in the middle. So I'm going to say 10 kilonewtons. So 10 kilonewtons. If we do, I'll label the distances. So we'll say that's 1. That's 1. And that can be 30 degrees. Okay. So first we want to do a free body diagram. So we can see that we'll have this. Since it's a pin joint, we'll have the Ry and Rx there. We have 10 kilonewtons here, and we also have this tension force here. Okay, so this is a free body diagram here. I'll just write in this 30 degrees. So if we want to find all of the forces here, this is how we'd go about it. First up, it's easier to do sum of the moment. So if we do the sum of the moment about this point here, we can eliminate all of these forces because they pass through this point. And so concentrate on this one and concentrate on this one. And so since there's only two variables, we know one, and we can get the other. So this is 1, 1. Okay, so first of all we want to break up this this tension force, sort of like I did in the last video, so into the x and y components. So we have t here, and so this side equals t sine 30, let's put 30 there, and this side equals t cos 30. Okay, so just have that there. Like, okay, so we've got that. Remember, they still act at the same point that t does, so I'll try and pull this down. Okay, so I'm going to redraw this diagram now using the t. Okay, so now as you can see, we have this x component that's going right across this line, and this also goes through this point here, and so it doesn't cause any moment about this point. So to find t sine 30, we're going to do the moment, call this one positive, moment about, let's call that A, point A equals 0. So this force is causing down, so it's a clockwise motion that this force is doing. So this is negative, since we've said anti-clockwise is positive. So it's negative 10 kilonewtons times 1 meter, since it's 1 meter away from point A here. And then this T1 is causing a positive moment because it's going in anti-clockwise. So we can do plus T sine 30, which is the force, times by the distance towards the point, which is 2 meters. So then we just go T sine 30 equals 5, and then T equals 5 on sine 30 kilonewtons, because we had kilonewtons for this 10. So now that we know what T is, we can do global equilibrium for some of the forces in the y direction. So we can write y, let's say this one's positive, and so we have negative 10 kilonewtons, so this is negative 10 kilonewtons here, so I'll just write in negative 10, plus this T sine 30 bit, so that's plus, so T is equal to 5 on sine 30 times sine 30, since it's T sine 30, and then plus Ry, because that's the other force that's acting in the y direction. And you can see that this cancels out and this cancels out here, so we have, sorry, this equals 0 because we have sum of the forces equals 0, and so we have negative 5 plus Ry equals 0, Ry equals 5 kilonewtons. Okay, and similar for the x, we do exactly the same process. Sum of the fx equals 0. So what's in the x direction? We got Rx and we got T cos x. So at the moment we've got them both pointing to the right, so they're both positive. So we got Rx plus, I'm just going to write in the value for T, which is 5 on sine 30 cos 30 equals 0, and then you can see that Rx equals negative 5 cos 30 on sine 30, which you can just plug into your calculator and get a value for. So that's an example of global equilibrium and changing up the, splitting up the forces into the different types.